Hello all. Welcome to this tutorial on how to animate transition using Booleans in Unity. This is continuation of a series of tutorials on Unity's animation system. In the last video we discussed Animator and its properties, which gave a default animation to a player character. But we can do more with animation, like taking input from user to play a different animation. This can also be an event happening in your game which requires a different animation to be played. This can be achieved using transitions defined in Animator and a script. We will discuss both in this tutorial. In our previous tutorial we played a default idle animation on our character when the game is played. During the course of a game we may want our character to walk when key W is pressed on keyboard. This example should make the things clearer on animation transitions and programming or scripting to achieve this objective. What we have in the Animator is a default animation state which gets played when we start the game. Let us have a look on where we ended as far as animation is considered. On playing the game, this is the default idle breathing animation which gets played. This box in orange represents the default animation state which gets invoked when game is entered and is represented by this transition line from entry to idle. To play the walk animation we need to import the walk animation FBX or OBJ file. To learn how to get the FBX files or OBJ files containing the character and animations, please refer to my previous tutorials which are part of this Unity's animation system series. I have provided the link to these tutorials in the description below. At this point I assume you have a file with character and a walk animation with Animator component applied on the character with all Animator properties set. If you don't and want to have an understanding of the same, I am also providing a link to the tutorial on how to animate a human character using Animator in the description below. So, the first step to setting up the walk animation is to import the FBX file with walk animation. It is worthwhile to mention here that we do not need the file to have the human mesh component. Let us have a look at this file walk, which I already have imported in my project. As you can see, there is no mesh component. The file contains the armature and the animation. Since this file is going to use the avatar of the base FBX file, discussed in previous tutorial, on Animator we set the avatar definition to copy from other model and provide a reference to the human avatar which we already created in previous tutorial. I will drag-drop the avatar and assign it like so. Also we make sure that the animation type is set to humanoid. Then we apply these changes to confirm. Now our file is set. We now create a new script to programmatically control the animation. We click on Add Component and search for New Script and click on New Script. We then type the script and give a name to script as animation. On click Create and add, the script will be created. I have the script ready with me, which we will talk about in detail now. We open the script in Visual Studio IDE for C# language programming. A C# program consists of a start function and update function by default. The start function is executed only once while update is called every frame. We first define a reference to the Animator component attached to character GameObject. When the game is started, then, in the start function, we get the Animator component attached to GameObject. The GameObject defined here is by default the GameObject the script is attached to, and which is the character in our case. The Animator component is stored in variable anim. Let me give a background of the Animator, which takes parameters of any of the four types of parameters. If we go to Animator Window and then to the Parameters tab, we can see that in the Parameters tab, if we click on the plus button, we can use any of the parameter types, which include float, integer, Boolean and Trigger. We will be using Boolean parameter in our case. Since we have two animations here, we define two parameters, one for idle and one for walk. These two parameters are accessible in the name idle and walk in the C# script, and depending on situations in the game we can set values to the parameters, making an animation state activated or deactivated. This is how we transition from one animation to other. This will be clearer looking at the code in the script. So, every frame we check in the update function that if the input key W on the keyboard is pressed down, then change the animation. Since we are using Boolean parameters, we call the setBool function of Animator Anim and set idle parameter to false, whereas walk parameter to true as in the code here. However, if key W is released and made up, we set the idle parameter to true and the walk parameter to false. Let us now go back to Unity Editor and play the game. We can see that the default idle animation is played on the character when game is entered. Now if I want to switch animation from idle to walk, I press the W button. The code we discussed earlier will acknowledge this key press and set the animation from idle to walk. But now if I release the W button, the code will sense that and set the animation back to idle. It is important to note here that we need to define each and every transition combinations in the Animator window. So, if we go back to Animator window, you can see the transition as lines represented by the direction or arrow. Unless we do not define the transitions here, the game will not interpret and make the transition. We will discuss more about the transitions now and how they are implemented here in Animator window. We will delete the walk animation state and rebuild again with transitions to understand better. We bring the animation state walk again by drag drop of the walk clip into Animator like so. We then define transition by right-clicking on the idle animation state and selecting Make Transition. A line will be created, and using mouse this line can be stretched. We stretch the line to walk animation state as we need to make transition from idle to walk. The line will snap itself to walk animation state. Left-click mouse button to confirm the transition. Since our game can transition from walk to idle state, also we do the reverse now. We first left-click on walk state and drag it to idle state and drag and left-click to confirm. You will see an arrow also on the line indicating the movement from original state to final state. Animation transitions allow the state machine to switch or blend from one animation state to another. Transitions define not only how long the blend between states should take, but also under what conditions they should activate. To view properties for a transition, click on the transition line connecting two states in the Animator window. The properties appear in the Inspector window. We will discuss properties to adjust the transition and how it blends between the current and next state. Has exit time is a special transition that doesn't rely on a parameter. Instead, it relies on the normalized time of the state. Check to make the transition happen at the specific time specified in exit time. If has exit time is checked, this value represents the exact time at which the transition can take effect. This is represented in normalized time. For example, an exit time of 0.75 means that on the first frame where 75% of the animation is played, the exit time condition is true. On the next frame, the condition is false. For looped animations, transitions with exit time smaller than 1 are evaluated every loop, so you can use this to time your transition with the proper timing in the animation every loop. Transitions with an exit time greater than 1 are evaluated only once, so they can be used to exit at a specific time after a fixed number of loops. For example, a transition with an exit time of 3.5 are evaluated once, after 3.5 loops. We can also do these settings visually here by moving the sliders. First we uncheck has exit time. So, let us say I move the sliders like this, and for the other transition we do settings like this such that the animation blends over time. Once done, we also need to define the conditions for each state. So, for this transition idle will be false and walk will be true. And for the other transition idle will be true and walk false. Let us play the game and see how transition works. On pressing W, we can see that animation blends over time and does not switch immediately. This is how we animate transition using Booleans in Unity. Subscribe, like, comment and share my channel for more fun videos and stay tuned for more. Thanks for watching.